Okay, good morning, everybody. And thank you for being here this Friday during Earth Science Week. My name is Sean Karoly. I'm a geologist for Geosyntec Consultants in Ann Arbor, Michigan, and I'm going to take just a bit of a sidestep away from the wonderful world of hard rock geology like petrology and structural geology and talk to you a bit about life as an environmental consultant, how you get the best of both worlds in working both indoors and outdoors, and also discuss how geology has played a role in some of my work here. And I guess I'll just make sure real quick that you saw the change in slides, it's not frozen on the first one.
You're fine.
Okay. So before I jump into all that fun stuff, I'll say a little bit about myself. I went to Oakton High School in Virginia and graduated somehow already over 10 years ago now. And high school was my very first insight into the world of geology with a class referred to as Geosystems. And Geosystems was a 4-part class that contains topography, astronomy, meteorology, and of course, geology. And after Oakton, I went to Radford University in Southern Virginia, where the entire first year I was an undecided major because I didn't know what I wanted to make a career out of at that time. I was leaning towards business, but also had geology in the back of my mind because it did really well in that section of geosystems in high school and genuinely enjoyed it. It came down to what would I find more enjoyable to work with on a professional level, and geology definitely defeated business in that regard. So I went with geology, and while at Radford, I was exposed to all the essential fields of geology, like hydrogeology and structural geology and mineralogy. And while still at Radford, I had decided that I wanted to pursue more than just a bachelor's degree and went to George Mason University to continue my education before diving into the real world, as they say. My experience at GMU was a bit of a different one in that it was the inaugural year for the school's graduate level geology program, which they refer to as Earth System Science. They have a very well-renowned climate program, and for the time being, that became kind of infused into my degree. Here I took a few different courses, which included paleoclimate, which is the study of climate on a geologic scale, so a really, really long time, and soil science and other kinds of classes. And of course, I couldn't forget my 100-page thesis on Milankovitch cycles, where I discussed how changes in the Earth's orbit around the sun might affect sediment deposits in the middle of the Atlantic Ocean. But no, unfortunately, I did not get to go to the middle of the Atlantic Ocean. In between those two degrees, there was a very crucial step in the process, which was geology field camp. And for me, this was hydrogeology field camp. I was most intrigued with the hydro course I took at Radford, and I wanted to get as much hydro experience as possible before grad school and work. So I enrolled in one of the few at the time hydrogeology specific field camps through the University of Minnesota. And it was a terrific experience being able to utilize geologic practices in an actual real world environment with people of a like mind. We looked at glacial till, glacier transported sediments on various slopes, and collected water measurements and analyzed geophysical data like gamma logs to help determine rock type, gauged streams to measure stream flow, in addition to a whole slew of other activities. And on the way up to northern Minnesota, we visited the St. Peter Sandstone, where at this location, I think it was near Minneapolis still, the outcropping was almost entirely pure quartz, and you could literally just peel fragments of rock off the outcrop like it was an orange rind. It was incredible. And field camp is important enough that most schools' geology programs require it, and important enough that one of AGI's issues in 2013 covered field camp and went so far as to slap right there on the cover that it is geology's rite of passage. So if you're in a college right now that doesn't have a field camp prerequisite for graduating, I would strongly encourage you to do so. And I wouldn't have considered field camp as strongly if it weren't for Alex Spear and Gordon Nord at the Mineralogical Society of America, as Radford University was one of those few schools that did not require field camp. So thankfully, during my on and off part-time internship with MSA, which I got actually largely in part because of my dad having a conversation with Dr. Spear. So thanks, Dad. They shared invaluable information and helped propel me to where I am today for sure. I also had an internship with the US Geological Survey in 2014, where I assisted their landslide hazard division in characterizing how susceptible oceanside cliffs and soil were to landslides on the coast of New Jersey. All of this led me to where I'm now with Geosyntec Consultants. So there have been quite a number of disciplines within geology to this point, and that continues to evolve while working with Geosyntec because of how environmentally focused it is. And people throw the word consultant around quite a lot in the work industry, but what does that really mean to be an environmental consultant, at least? And for me and for most of us at Geosyntec, we use our various backgrounds and expertise to provide data, opinions, get samples and results and analyses and recommendations for moving forward and other things to a plethora of clients because of our knowledge in the industry and issues that a company may have. And most of the time, this revolves around remediation. Basically, a company may have an environmental problem and we say, hey, we're experts with this kind of stuff. Here's how we can fix it for you for a price, of course. And geoscientists can find themselves in several different fields for sure. And the top two categories here both can often relate to environmental consulting. And when I was searching for jobs online after graduating, I found that a lot of opportunities, especially ones related to hydrogeology, were with environmental consultants like Geosyntec. There are definitely job opportunities in other fields too, though. I mean, I went to a workshop at Lehigh University where I found out about jobs in oil and gas through Exxon and Chevron in Texas, and I had a job offer to do tons of geologic mapping, so the real true geology, as they say, for the South Dakota Geological Survey before eventually deciding to take up Geosyntec's offer instead. At Geosyntec and many other environmental consultants, it truly is a team atmosphere and a bunch of different teams within the company to help tackle projects. In addition to geologists, Geosyntec has other experts in the science industry like biologists and toxicologists, and we rely heavily on engineering support from our environmental and civil and geotechnical engineers to help make sure that our solution will hold up for years to come. And with so many different areas of expertise and types of professionals within the company, we have a lot of different clients who we provide consulting for. Huge companies such as ExxonMobil and NASA, down to small business like the mom and pop dry cleaner just down the road. Our Alabama and Florida offices are lucky enough to have an ongoing project at NASA's Marshall Space Flight Center, where they're developing a rocket to go up to Mars in tandem with a rover to collect rock and soil samples from Mars. So that's a really cool opportunity for Geosyntec to help with the environmental side of things at that center. And the list goes on with people that we work for, legal teams, state and federal agencies, and big names in the power industry like American Electric Power and TC Energy, formerly known as TransCanada, the latter of which owns and operates the Keystone Pipeline System, which you may have heard of. And hey, they had a bit of an infamous run over the years of news headlines, including oil leaks like this one in the wilderness of South Dakota, where over 400,000 gallons of crude oil leaked into agricultural land. So what is it that I do specifically? Well, as I said earlier, I have the luxury of splitting my time up in both indoor and outdoor environments, like many geologists do. And field work is our beloved term to describe all of our outdoor tasks, but it can also be indoor too, away from the office computer for company projects, like overseeing a drilling team bring up soil and rock cores, installing locations for collecting groundwater samples and soil samples and air samples, and doing the collection of these samples as well. The picture in the top left has what I'm most familiar with, and that's all the equipment we use for collecting groundwater samples, or at least some of the equipment we use. And yeah, groundwater wells aren't always necessarily like outside in a park or something nice. This one is right in the middle of a manufacturing building, which I'm actually going to later today after this talk by coincidence. And it made for a very interesting and loud working environment. The picture in the top right shows a sediment sample tube with a good buddy of mine, Rick, who is a senior field leader and construction manager at Geosyntec. And for samples at this location, we were actually out on a lake, on a barge with a big drilling rig mounted on top of it to collect samples beneath the lake bed. So that was really neat. In the picture in the bottom left, I'm actually collecting an air sample, which has become more and more of a common thing for me to do in the field, and something I did not see myself doing for a job when I was in college, when I was studying rocks and like not the air and nor environmental stuff. And just for a brief overview, because I do think it's interesting, that air sample is collected due to a phenomenon called vapor intrusion. And a lot of my projects deal with contamination below the surface because of leaking chemical compounds, dumping, just overall poor management from companies decades and decades ago that is causing impact today. With vapor intrusion, it is commonly a group of chemicals called volatile organic compounds that volatilize, so evaporate and disperse from already contaminated groundwater into the soil and subsequently move upward through the subsurface until it reaches and penetrates basements of people's homes. If residents are in these areas where the vapor has intruded for long periods of time, it can result in some serious physiological issues if concentration levels are high enough. And this is particularly a concern in Michigan, where I am, where the groundwater is often very shallow and the soils just below ground surface are sandy and allow vapor to easily transmit through, unlike clays, which inhibit flow. But for the most part, I do find myself in the office working on another whole suite of things like writing lots of reports. No, writing papers and reports doesn't really ever end, does it? Creating maps and figures using geographic information systems software or GIS, using Excel, of course, and even some 3D software like Earth Volumetric Studio to show our clients just how deep or shallow the contaminated area lies. There are also a handful of folks that use groundwater modeling programs like Actisolve and ModFlow to determine, for example, how long it might take for contaminated groundwater to affect a city's drinking water wells. I do, of course, want to give a couple examples of field projects at Geosyntec where geology has played a pretty key role in the lifespan of the project. The first of which is with one of our oil and gas clients, where I've been groundwater sampling many times. We focus on groundwater wells closest to the source of contamination, like where the leak occurred however many years ago, or where we thought it might have occurred, and wells with good recharge and high water columns, a large amount of water within the well, like those typically set in very sandy and gravelly layers that allow water to flow through freely into the well in order to be able to pump out a lot of water. And without going into too much detail, we want to pump out a relatively high volume of water out from wells in order to collect samples that are representative of the groundwater within the aquifer. And with these samples and data from the laboratory that we sent them to, we were able to create figures and maps depicting the groundwater plume, as they call it, and also use statistical analysis based on past results to show how the contaminated area was changing over time or lack thereof. And with all of that data and the fact that there was a clay layer up to dozens of feet thick between the surface and where the bulk of the contaminated zone was around 100 feet deep, we were able to convince both the client's environmental team as well as the state of Michigan that future environmental remediation work was not necessary, provided we could close off part of the site so they don't extract groundwater or construct any buildings on a portion of it, just that portion of the site. And this saved this oil and gas company potentially hundreds of thousands of dollars in remediation costs. And here I was in the picture on the right, not doing the operation of the machinery, of course, because that's not in my job description, but rather overseeing them pulling the groundwater wells out of the ground as part of closing down the site. And you can probably tell from the pictures that this location was in pristine wilderness or the middle of nowhere, depending on what you want to call it. And places like this made fieldwork pretty darn fun, provided that the weather cooperates, of course. Another project that really had some geologic ties was one that involved X-ray diffraction, which some of you might know and maybe even have used, but XRD is a technique in general that allows us to see the crystal structure and physical properties of a rock by crushing it into a powder form. And for this project, we had a client that was potentially responsible for high lithium concentrations at nearby groundwater wells that they installed on the site themselves. However, we thought that it was naturally occurring lithium associated with shale and clay lenses with rock cores that were drilled up. We found that the geology at the site was actually a bit misunderstood, with little documentation of the shale and thought to be predominantly just limestone. And after bringing up bedrock cores from drilling, we first collected groundwater samples to be analyzed for their metals abundance. And sure enough, lithium concentrations were very high in the groundwater samples from shale intervals and not nearly as high in the limestone interval samples. And when the XRD confirmed that these lithium-bearing layers were a shale based on their relative abundance of minerals, it confirmed to us and the client and the state agencies that these scary high lithium concentrations at groundwater wells were naturally occurring and not the result of some sort of a leak from our client's operations. And this saved this company potentially over $1 million, definitely potentially 7 figures, with the alternative of having to assume further responsibility and take action to clean up the lithium contamination. I wanted to conclude with a few of what I thought were very important points just from my own personal experience in finding work. The first of which is how far to go in school before looking for a job. I said earlier that I made the decision to get a master's degree largely due to the belief that it would pretty much guarantee me a job. And while I think this did play a role in ultimately getting multiple job offers after school, I wouldn't say it's completely necessary for this field. We did get our most recent hire a month after she got her bachelor's degree because she killed it in college with grades, was well-spoken, but more so had great internship and volunteer experience, which included interning with us just a couple of years ago. An internship with a company can go a long, long way. And a great way to find out about these opportunities in the first place is through career fairs at your university. That being said, higher levels of education, again, certainly can help in nailing down job opportunities for sure. Definitely have to be persistent when searching for these opportunities. I couldn't tell you how many internships and part-time jobs I applied for before I landed the one with the U.S. Geological Survey. It was a similar process before I was lucky enough to have a few different job offers after getting my master's degree. The job offer with the South Dakota Survey came because I emailed the Minnesota State Survey, told them about my experience with the university and the field camp, and asked if they had any openings. They then relayed me to South Dakota. And after you graduate college, if you're serious about going into the work industry or continuing education further with geology, you should be able to take the Fundamentals of Geology or FG exam, and you should do this as soon as possible, as it covers a lot of stuff that you learn just from your coursework. And I found this out the hard way when I waited 5 years after getting my first degree to take the exam, and it was definitely very difficult, but I managed to squeak by, of course, extra studying no matter what is required for this piece of the exam. And there are a lot of folks within Geosyntec and other environmental companies that have their professional geologists or professional engineers licensure, and it definitely helps securing contracts and other work for the company. Lastly, if you have any questions or further curiosities about something geology related, obviously go to your professor first, but there are actually a lot of resources online, especially just even with YouTube videos I found recently. You can pretty much take virtual field trips with folks from all over the country and beyond as they talk about different geological concepts. And they're just uploading them on YouTube for fun and maybe for students of their own. And it is fun and different because you're watching a video and not taking down notes off a PowerPoint like always. Yeah, so there are so many different kinds of opportunities, not only with geology as a whole, but also just in the environmental sciences alone. I get to travel to so many unique places that my professional job, my time at Geosyntec alone has brought me to, of course, Michigan, but also Ohio and Indiana, Kentucky, Illinois, Missouri, all over the Midwest. It truly is exciting to be able to work in all these different environments and collaborate with all these different people, biologists and engineers and construction managers and geochemists, and the list goes on. And it's so often that I can continue to build on the experience I already have with new things. So it really is an awesome career. So yeah, so that's it. If you have any questions, feel free to ask them now, type them in the chat. I've also put my email address on this slide. So if you would rather take the time to think about and write out a question and send me an email instead, that's perfectly fine. So yeah, thanks again to Alex and Anne for this opportunity, and thanks for all your time.